Third tutorial, data structures. First question, create a function called list of primes that takes one argument n, an integer, and it returns a list of all the prime numbers up to n, including n. First of all, I will create a helper function that I will name isPrime. This function takes one argument, n, an integer, and it evaluates if n is a prime number or not and return true or false. If n is strictly less than 2, return false because the first prime number is 2. If n is strictly less than 2, in this case it is not a prime number. If n is strictly greater than 2, in this case, for every integer between 2 and n minus 1, compute n modulo I, this number, this integer, and if it is 0, it means that n is divisible by I, and in this case, return false. For all other cases, return true. Now I define my function, list of primes. This function takes one argument, n, an integer. It evaluates all the integers from 2 to n if they are prime numbers and return a list of prime numbers. First of all, I will create a variable called primeList and I will assign an empty list to this variable. Then, for every integers between 2 and n, including n, that's why the end of the range will be n plus 1, I will check if the integer is prime or not. If the integer is prime, in this case, with the method we learned, append, I will add this number to the prime list and at the end return prime list. In order to check, I create a variable called y. I assign 100 to y. I compute list of primes of y and I assign to a variable that I called result. And then with the help of f-string, print list of prime numbers up to variable y, including y, colon, new line, tab, and result. I run my code. List of prime numbers up to 100, including 100, are 2, 3, 5, up to 97. You can check all of these integers are prime numbers. Now I want to make the same thing, but first of all I will uncomment last two lines and I will use list comprehension. I create a variable called list of prime numbers and I create a list with list comprehension, x for x in range y plus 1, because I want to include y also, if isPrime x. It means that for every integers in this range, check if this integer is prime. If it is so, append to this list. And with the help of the f-string, print the result. I run the code. The first line we already seen, but the second line, list of prime numbers up to 100, including 100, generated with list comprehension, are exactly the same. Question 2. Create a function called wordCounter that takes one parameter called text, a string object, and counts how many times a word is used in the text and return it. For example, for example 1. In this problem, I will use 3 string methods. The first reference you have to use about Python is docs.python.org, and the URL address for string method is here. As in the previous example, instead of doing everything in a single function, first I create an auxiliary function called generateWordList. This function takes one argument, text, a string object. It performs 3 tasks. It splits the text into words, it strips punctuation from the words, and finally lowercase the words. In this function, I will introduce 3 string methods. The first one is split. If no argument is provided, it splits the string at every white spaces, which means every word, but it can be followed by a punctuation and return a list. The second function is strip. I want to get rid of punctuations from the words, if any. And the last string method is lower, in order to lowercase all the words in my list. So I compute text split and assign it to a variable called wordList. With for loop for I in range of length of wordList, I compute with every element of the wordList strip function, strip method, and lower method, and assign the result to the same place. And at the end, return wordList. Now I can define my final function, word counter. This function maps every distinct word in a text and their respective usage numbers and returns it. First of all, I create a variable called how many word and assign an empty dictionary to it. Then, with the help of the first function, auxiliary function, I compute generate word list of text and assign to a variable called wordList. And for every word in the word list, if word not in how many word, the empty dictionary at the beginning, then I will create a key value pair in how many word. If the word is not in how many word, the key is not in how many word, in this case I will assign the value of the keyword 1. But if the word is already in the how many word keys, in this case I will increment the value of the keyword by 1, and at the end return how many words, the dictionary. In order to test my code, I create a final text with a concatenation of 2 texts. I compute word counter of the final text and assign to a variable called result. And with the help of fstring, I print a dictionary that reveals number of times a word is used in the text is new line, tab, the variable result, new line, and I also compute length of result, and there are totally length of result distinct words. I hit the button run. A dictionary that reveals number of times a word is used in the text is, for example, when is 2 times, you is used 5 times, for is used 3 times, generous is used 1 times, will is used 2 times. And at the end, There are totally 46 distinct words. Third question. Create a function called distinct words that takes two arguments, text1 and text2, two string objects, and returns a set of words present in the text1 and not in the text2. In this question, I will need the same auxiliary function I created in the previous example. Generate word list function. As you can remember, this auxiliary function, split the text. It creates a list, word list. Then, for every word in this list, it strips punctuations from this word, if there are any, and it also lowercase all the words. And finally, it returns the word list present in the text. Now I create a function called distinct words, and it takes two arguments, text1 and text2, two string objects. This function returns a set of words used in text1, a string object, but not in text2, another string object. First of all, I will generate word list of text1 and assign to a variable called word list1. And I do exactly the same thing for text2 and assign the result to a variable called word list2. I know that sets generate distinct elements from any iterable. So I create a variable called unique words 1, and with the help of set constructor, I assign to this variable sets of distinct words in word list 1. And I do the same thing for word list 2 and create a set called unique words 2. Then, with the difference operator, I compute unique words 1 difference unique words 2 and assign the result to a variable called result, and finally return the result. To test my code, I have two texts and I compute distinct words text1 and text2 and assign to a variable I will again call result, and with the help of fstring I print set of words present in text1 and not in text2, colon, new line, tab, result, new line, and I will give additional information. There are totally length of result words. I hit the run button and set of words present in the text1 and not in text2 are really, phrase, then, just, thank. There are totally 5 words. Fourth question. Create a function called perpendicular triangles that takes one argument and an integer and returns all possible perpendicular triangles with sides strictly less than n. Then check for n equal to 50. At the end, it should return a list composed of tuples, such as 3, 4, 5, 6, 8, 10. Before jumping to the final solution, I want to show you how I will get square root of a known integers without using square root method. Imagine that I assign 10 to n, create an empty list called squares, and for every integers from 1 to n, I compute the square of this integer and add to the list squares. I could have done the same thing with list comprehension. For this example, squares list is 1, 4, 9, 16, 25, 36, 49, 64 and 81. Square root of any integer in the list squares is the index of that number plus 1. Plus 1 because the zeroth element of the list is 1 and not 0. For example, the index of 25, 0, 1, 2, 3, 4 is 4. So squares of 4, index 4 is 25. 4 plus 1 is the square root of 25. To print the square root of 49, we learned that sequence object method index returns the index of first occurrence of x. So, assign 49 to m, squares index m plus 1, compute squares index m plus 1 and assign to the variable called square root, then print f string square root of m is square root. I hit the button run and square root of 49 is 7. Now I can go to my final solution. I create a function called perpendicular triangles that takes one argument and an integer. This function computes squares of all integers from 1 to n minus 1 and store in a list called squares. It also computes the sum of squares of all integers of j from 1 to n minus 1 and k from j plus 1 to n, and checks if the sum is equal to the square of an integer by the operator in. If so, it means that three integers are three sides of a perpendicular triangle, and it appends the tuple to the list called perpendicular triangles list and return it. Create an empty list called squares for every integers from 1 to n, compute I square, add to this list. Create another empty list called perpendicular triangles list for j in range 1 to n minus 1, for k in range 1 plus j to n. Hypotenuse square, compute j square plus k square and assign to a variable called hypotenuse square. Here I didn't use 1 to n, but I used 1 plus j to n, because if I use 1 to n, it will create symmetric results such as 7, 24, 25 and 24, 7, 25, but these two represents the same triangle. Think about why not from j but from 1 plus j. Then, if hypotenuse square is in squares in this list, in this case, compute hypotenuse squares index plus 1 and assign to a variable called hypotenuse, and append the tuple jk and hypotenuse to the list called perpendicular triangles list, and at the end return perpendicular triangles list. Assign 50 to x, compute perpendicular triangles for x and assign to a variable called check, then print list of all possible perpendicular triangles with sides strictly less than x, colon, new line, check, new line, and give the additional information. There are length of check triangles. I run my code. List of all possible perpendicular triangles with sides strictly less than 50 is a long list. The first element is a tuple. All of the elements are tuple. 3, 4, 5. Next element is 5, 12, 13, 6, 8, 10, etc. And totally there are 18 triangles. Homework. First question. Create a function called factorial_in that takes two arguments, low and high, two integers. It returns a list of integers that have a factorial greater than or equal to low and strictly less than high. Test it for low equal to 10,000, high equal to 10 million. Create a function that takes one parameter, a string object called text, and returns a directory that counts every character in the text, including white spaces. Test your code for text 12 twins, 12 tweaks. Third question. Sort the list to sort, 6 to 94, etc. in ascending order without using sort method. To solve the third question, you might need to swap two successive elements of a list. For example, you might need to swap a of I with a of I plus 1. First, create a variable called temporary variable. Assign a of I to it. Assign ai plus 1 to ai. And assign temporary to ai plus 1. Last question. This question is a little bit challenging. Imagine there are 6 towns called A, B, C, D, E, F, and they are connected. The distances between connected towns are as follows. It's given in a directory. The keys are the paths from A to B, and the distance is the value of the key. AB2, AC7, AE5, BC3, BE7, CF11, DF5, ED3. Find the shortest path from A to F, that is AF. To solve this question, find all possible paths from A to F. Then, for every possible path, compute the distance of the path and identify the shortest. There are 2 points to consider. The first one, at the beginning you have 2 node paths such as AB from node A to node B. But it means that there is another path, there is also a path from B to A. That is another path called BA. The second point to consider is when concatenating paths with 2 mode paths, you should avoid to return to a node that the path has already passed through. If you want, you can watch the next video where I explain the solution with pseudocodes.